AET 105, Chapter 1, Section 1.7, Fixed Point, Floating Point, Scientific and Engineering Notation. Fixed point format requires that the decimal point appear in the same place each time. In the floating point format, the decimal point appears in the location defined by the number to be displayed. So these first three examples are fixed point. Okay, the decimal point is always in the same place, depending on the number to be displayed. And then if left in the floating point format, the results will appear as follows in the above operation. So you can see that the decimal point changes position here drastically between these three examples. Scientific notation we won't be using too much in class, but its general format is like x point xx, and this is e standing for exponent, which is 10 to the power of -1 in this example. This last number is the power. This is the power of -1, power of -2, and the power of 3. So again, these are all the same number, but just shown in different in different formats. Engineering notation we're going to be focused on in this class. All powers of 10 must be 0 or multiples of 3. So 3, 6, 9, 12, -3, -6, -9, -12, and the mantissa must be greater than or equal to 1, but less than 1,000. Okay? So that greater than or equal to 1 is not as hard. It's just that's a rule of thumb, but it's definitely not exactly right, because they're showing you that the mantissa is this number here, this 333.333333, or the 62.5, or the 1.15. Notice that they're always greater than 1. Sometimes the book will make it less than 1, like a 0 point, and then 2 or 3 more decimal points after that, then the power. So in engineering, you could see the difference of the notation between scientific and engineering. We always use powers of 3. And then with a 2-place accuracy, it narrows it down to numbers that look like this. Multiplication factors. This table is very important. We are primarily going to focus, I'd say, from giga all the way down to pico. Example, 0.001 is 10 to the -3, which is milli, which is a small m. And then that would be 1,000th, and then 1 millionth would be 10 to the -6 micro, or mu, Greek letter, it looks like a U. And then 1 billionth would be 10 to the -9th, or nano, with a small m. And then going in the direction greater than 0, or I'm sorry, greater than 1, you have 1,000, which is 10 to the 3rd, which is kilo, or small k. 1 million, which is 10 to the 6th mega, or capital M. And then 1 billion is 10 to the 9th giga, which is capital G. Conversion between levels of power of 10. Replace the prefix by its corresponding power of 10. The prefix would be this, or this symbol. Rewrite the expression, set it equal to an unknown multiplier or a new power of 10. Note the change in the power of 10 from the original to the new format. So what they're saying there is, let's say you have a number that looks like this, and you want to convert it to a different prefix. To convert it to a prefix that differs by, let's say, a power, it would be 10 to the 3rd, which would be a jump from one, like let's say milli to micro. So in this example, 331.33 times 10 to the negative third. Excel is going to represent that like this, but if you move the decimal point 3 to the left, that makes this a smaller number, so you have to make this a bigger number, so add 3 to it, 10 to the 0, which again would be 0.33133, with no power of 10, 10 to the 0 is 1. If you had 482 times 10 to the third, that would be 482 e plus 3. And then if you move the decimal point over again 3 places this way, you're making this a smaller number, so you have to make this a bigger number. So again, you would write it like this. Either one of these is acceptable as far as engineering notation goes. They're both the same number. So whether you choose it to write it this way or write it that way, that would be fine. And then conversion between systems of units. Set up the conversion factor to form a numerical value with a unit of measure to be removed from the original quantity in the denominator, and perform the required mathematics to obtain the proper magnitude for the remaining unit of measurement. So again, they were talking about converting between, let's say, metric and English. Symbols, the equal sign with a slash. I'm sure you guys have all seen this, but we'll go over it. It means not equal to, so 6.12 is not equal to 6.13. They're close, but they're not equal. Greater than, example looks like this. Much greater than is a double greater than symbol. Likewise, less than, much less than. Greater than or equal to looks like that. Less than or equal to, approximately equal to, this would be an example for pi. The sigma symbol equals sum, so the sum of 4, 6, and 8 equals 18. Absolute magnitude, it would be a vertical bar on each side of a variable or a number. So the absolute magnitude or absolute value, if you write it like this, that means that A can actually be negative 4 or positive 4. 3 dots means therefore x equals the square root of 4, therefore x equals plus or minus 2. And 3 lines, like an equal sign, is by definition establishes a relationship between two or more quantities. A colon B is the ratio defined by A divided by B. And then A colon B equals C colon D is the proportion defined by A. A is the B, is C is the D. A divided by B equals C divided by D, like a proportion. Conversion tables, 2.5 miles to meters require that we multiply 2.5 by a conversion factor. I like to use ones on the computer, which would be like a convert, something like this, where you can convert any kind of variable to another one. You have the input and the output, and let's say you wanted to convert centimeters to inches. Then you just type in your variable here and you get it inches out, or you guys can use this for different classes, but they have ones for energy in here and they have ones for power in here, and that's pretty much the only ones that we would ever use. But we typically don't. This is not something we typically do in this class. And the last section in chapter 1, know your calculator. This is my little adder. Examples, what I mean by knowing your calculator. Order of operations using parentheses. We're going to be doing a lot of problems that involve this. It would be like, please excuse my dear Aunt Sally, which would be parentheses first, then exponents, then multiplication, division, addition, subtraction. So those are the order that you do those in. How to do angles, sine and cosine to convert back and forth between the sine of an angle and the angle itself. The difference between degrees and radians, and not really in this course, but in the next course, complex polar form versus rectangular form. That would be for complex numbers when we do AC circuits.